Hello, everybody, and welcome to the Reuse Company webinars. The topic for today is implementing ISO 15288 V&V processes using the V&V Studio. My name is Cecilia Carlson, and I will be hosting today's webinar. With me, I have Juan Yorenz, CTO at the Reuse Company, and he will talk about the V&V processes. This is the agenda for the webinar. First, we will have a short presentation of the company and the presenter. After that, Juan will talk about the systems engineering context, the verification and validation process, and then we will see a demonstration. Finally, we will have some time for questions. First, a few words about the Reuse Company. The Reuse Company was created in 1999 as a spin-off from a university in Madrid, Spain, by system and software engineers. Our headquarters is in Madrid, but we also have an office in Stockholm, Sweden, and a delegation in Japan, in Tokyo. In 2021, we are planning to open an office in the US. Our mission is to promote a reusable, scalable, and global solution to a smart and interoperable systems engineering environment. And we do this by offering a semantic knowledge-centric approach. TRC is the Reuse Company is also called TRC. We like to say that it's easy to remember if you think of T like in traceability, R like in reuse, and C or almost Q like in quality. You can also apply these concepts to other topics. Who is using our technology? Here you can see some of the companies that are users of our system. They come from quite different industries like aerospace and defense, energy, automation, and healthcare, but also from other industries. Let me introduce you to the presenter, Juan Yorenz. He's a systems engineer professor at the University Carlos III de Madrid. He is also the CTO at the Reuse Company, and he has been the president of the Spanish chapter of INCOSE. Juan is a member of INCOSE and the Spanish chapter of INCOSE. He has been the chair of the INCOSE Ontology Working Group. He is a member of the INCOSE Requirements Engineering Working Group, and he is a contributor to the INCOSE Guide for Writing Requirements. He also has the CSAP and ESAP certifications. So let's start then with today's topic. Hello, Juan. Please tell us about V&V processes.
Yes, hello, Cecilia. Thank you very much. Good morning, good afternoon, and good evening. Today's webinar is going to be dealing around the digitalization of the verification and validation process. And we are going to have as the common template or framework the definition of these processes around the ISO 15288 standard. So I'm going to do a very, very small context declaration before we get into the topic. V&V model, lifecycle management, ISO 15288, you know much more than me, you guys. So I only would like to put the focus on a couple of slides where the V model is explicitly presented, and how is this, even in this standard way of describing the V model, even is this just dealing with some kind of verification and validation. So the first slide, coming from the handbook, you can see that, of course, the typical vertical line on the left side of the V model, where we're just working on different baselines. And a little bit described in the handbook is, of course, that the off-core topics around them are starting to understand the notion of validation. So even if we are on the left side, we have to start discussing it if the proposed baseline is acceptable. In a way, we have to start preparing everything for being able to verify and validate even the left side, and then when we come to the right side and the right side. So, of course, when we are at the right side, the verification and validation concepts are very, very specific or stated clearly. So are we building the baseline? Are we building it right? The product, are we building it right? Or are we building the right thing? That's a typical stuff. So in the context, the V&V model is describing in a way that we have to deal with V&V in It's something that we all know, so it's nothing new. Let's start directly after this very small context. Let's start with the topics. So we go into the definition of the verification. Start with the verification process. I'm going to read, so sorry for that, but it is quite straightforward, the definitions that exist. The purpose of the verification process is to provide objective evidence that a system or system element fulfills its specified requirements and characteristics. So a little bit more in detail, the purpose is to provide evidence that no error, defect, or fault has been introduced at the time of any transformation of input into output. Okay, I would like to connect the notion of verification in a theoretical way to fulfill requirements, but in a practical way to try to avoid error, defect, and fault, because this connects this notion very much with the notion of quality, which you will see that is something that we like very much to do. And we are a tool vendor, as Cecilia has said, so we like to provide tools for digitalizing things. And in this case, we want to digitalize the V&V process. And one way of digitalizing it, of course, is providing evidences of fulfillment and requirements. Another way is to provide this evidence connected with errors. So quality and defects and all that stuff. So it's always the notion of something that has been made right. Verification is something made right, okay, according to whatever reference that we are going to use, requirements or models or the system itself. Okay. The purpose of the validation process on the other side is very, very much the same thing. It's again to provide evidences, objective evidence. But in that case, the context is different because you see the system, when it used, fulfills its business or missions, objectives, and stakeholder requirements. So it is almost saying the same, but in completely different way. In theory, you have to have the system in use, the element in use, and you have to use as a reference the stakeholder requirements, considering that the system is achieving its intended use defined on them, operational environments. So that means that verification and validation, even if they are more or less the same, they're completely different. One faces in a way stakeholder requirements, validation, stakeholder requirements. The other one faces in a way system requirements. So, so there's this quite differential context on the topic. So in order to clearly describe it in a way that we are going to remember, so build the right thing and build the thing right. If we start with validation, we say we build the thing right, or this is verification, and then validation with the right thing. Okay, so context is different, as we said, the scope is different, but both can be digitalized in the same way with the same tools. That's why we consider it is possible to use one tool for digitalizing, for managing the verification and validation processes. Now, what to verify or what to validate? So if we go back again to the references that we use, standard and the handbook, it's clear. We have to be able to verify everything. That's just so clear. Okay, it's not that even if at the beginning I just read the system to verify the system and to validate the system, it's clear. The verification process can be applied to any engineering element that has been contributed to the definition and realization of the system itself. So we can verify everything. We should verify everything in principle. Remember that the less errors we get early in the life cycle development, life cycle model, the better it is for the whole system. So if we can verify and validate things before we just are in the hardware side, it would be very, very good. Okay. So, so in order to provide a, let's say, simple sentence, the verification process stands for providing evidences, objective evidence that whatever engineering item has been built right. Okay. The result of this notion is that we should apply verification and validation in the left side and in the right side. And we eventually have to not only think on verifying from right to left, I mean verifying the system, but also verifying requirements or designs against requirements, requirements against a set of rules, and we can have L to L or write to L or even write to write verification and validation. Okay, so because we are a tool vendor, I would like to put you a little bit in a trap somehow. Okay, what to verify? This is a small controversy, and it is important for us because we produce tools, so we have to provide the tool considering that you are thinking on verifying the system against requirements or verifying requirements against the system. And it's not so clear what is the way we should do, because it's not so clear neither in the documentation what is the way to do that. So if you think yourself, are you verifying the system against several requirements? Are you verifying requirements against the system? When you go into requirements engineering, requirements development, always it's saying that the requirement must be verifiable. This is a property of the requirement. But then at the end, you verify a system. So how is this working? Okay, and it's not me the one that's going to tell you how. It is you guys the one you would like to define it. Before the maturity of systems engineering, tell us what is the concept of for us to understand this approach. I mean, in which way should we have to understand what to verify against what? Before the maturity, just tell us which is the way. We are going to accept both ways. Okay, you see here in these tables that the definitions coming from the body of knowledge or coming from the handbook. And in all of them, you can see that there's quite a lot of ways to interpret, to understand the way. You see, to verify a system, it is to check its realized characteristic or properties against its expected design characteristics. Okay, so this is a kind of, you don't know how to understand that. So let's go into, you see, I have here this this position or opinion, and I have here this opinion. Okay, when I show you that arrows, it means that the definition described in the different documents seems to be thinking on the notion of verifying the system against the requirements. Okay, in this slide, this graph image that is in the handbook, you also can see that you verify the system against. This is clearly describing that you're verifying the system of interest against the requirements. Okay, in this graph. But then you go into this page, page 61, for example, or page 85, and then it's not clear, because in this page, when you are just describing a verification action that we will see in a second, verification action describes what must be verified, and now it suddenly says that you verify a requirement on which item, and then you see that you have the system. So somehow the system is on which item. So here now suddenly they just turn it around and say that you're verifying requirements against the system. For us, it is you decide what you would like. So for us as a tool vendor, we are going to provide you means for you to decide which are the verifiable item. If you want to verify the system against requirements, you define that the verifiable item is the system. If you want to do it in the requirement, you define the verifiable item is the requirement. And in which way are we going to do it? Just by allowing you to define connectors to the elements that you would like to verify. So if you want to verify the requirements against the system, you just connect to a requirements management tool, and what you will get in the verification and validation studio, VMP studio, you will get in the verifiable items, you will get requirements. And then you would be able to verify the requirements. While if you want to verify the system, you have to digitalize, to find a digital way of finding the system and its parts in here. So that could be, perhaps you can connect to Teamcenter, or you can connect to an Excel where you have all the different bill of materials or product breakdown structure, so that you have different systems or subsystems instances here in a digital way, and then you would verify or validate them. That is a little bit the way we consider that. Okay. So how to verify or how to validate? So in order to do that, we consider the notion of the verification action. So it is just simply what it says in the standard. The standard says that in order to verify, you have to provide a verification action, which is what you have to do. It defines a structured representation of the necessary information used to assure that the verified element fulfills its specified requirements and characteristics. So you see, you have to, in order to digitalize verification and validation, you have to manage verification actions. And in a way, the information that you have to put in a verification action, which is, for example, a verifiable item, or the source items where you're going to use to verify the verifiable item against, or the verification technique, or the resources, or the results and everything, you have to put this inside a digital version of the verification action or validation action, and then you will be able to manage verification and validation. It's simply that way. So that means that the process of defining, configuring, scheduling, filling, analyzing, managing, and reporting verification actions can be described as verification process. The same for validation. Okay. The notion of a verification action describes what to be verified, mainly on which item, okay? And that's why I just put here the system in both, because then you can select which way would you like to work. The expected result, what you are going to verify, the verification technique to apply, and on which level on the composition of the system you're going to work. And of course, you have also to include the obtained result. So you have the expected result, and then you have to get or record or put or calculate the obtained result of the verification action. So the performance of a verification action mainly means that you compare the expected result, whatever it is, with the obtained result. And that's why a computer tool, if you have an expected result and you get an obtained result, a computer tool can do for you this calculation, which is straightforward, and tell you this verification action is good or this verification action is not good because it didn't compare or it doesn't compare with the result that we expected. The VMV Studio is concentrated on this calculation. So how to evaluate? It's again very stupid simple, sorry for that. You get a reference. This reference is used to include in this reference information, like for example, the expected result. You get verifiable items, the item you want to verify, and you compile everything here in a verification action, including the expected result. And then when you do the verification, you just introduce the obtained result. And of course, a verification action, manually or using our computer tool, would be to compare if the expected result matches with the obtained result. In that case, if the expected result matches, then you can say that the verification action is fulfilled. If no, you can say that it is not fulfilled. Okay? So the VMV Studio is capable to run this comparison automatically. And of course, the computer tool is capable to then tell you the yes or the no. The issue is that we don't think that a computer should be able to decide by itself if the verification action was verified. I mean, if we verify the system just because a comparison is done or not. So what we do is we suggest the yes or the no. So the computer tool suggests a yes if the correctness comparison, if the comparison is correct, or no if not. It's a suggestion. And then humans must go there and just say yes or no. Okay. So this is a little bit what I described. You see, a suggested yes, and then the engineer decides, or a suggested no, and then the engineer decides. Okay, so relevant concepts here. The expected result, the obtained result, as I told you, and then we have to get into comparison operation and the verification action states. So let me talk few minutes on these concepts. The VMV Studio methods for obtaining results. So in which way can we automate the gathering of the results, okay? So there are several methods. The first one is manual insertion. So what means is that if you select the manual insertion, called automatic rule here, if you select the manual insertion, then you have to fill manually the obtained result. Let me put you an example. If you go to, if you have to see if the number of screws in a welding or the number of blocks in a welding is 20, because you have to get 20, and it's just stated here that you get a 20, then you go to field, you go there, you climb up in a wing in an aircraft or whatever, and then you just count, take some pictures or whatever, and then you count 1, 2, 3, and then you say it is 19, and then you just fill here 19. And you can put evidences here, videos, whatever you need, and then you just leave the 19 here. What a computer tool, of course, can do is to check if the 20 expected matches by this operation by the 19 there. Okay, this is a little bit how the manual insertion works. The human must open a verification action and fill a 19 here. But once it is done, the computer can tell that this verification action is not suggested to be fulfilled because 19 is not 20, and then you didn't have a design precision. So what you were asking for 19, sorry, for 20, and you got 19. The second option to populate information is called checklist. So what means is that if you want to have a checklist as the way of performing a verification action, you have to go through a checklist. The verification action would allow you to populate the yes or no or not available answer to the questions in the checklist. And that means that the computer is going to compute or calculate the number of yes and the number of no, okay? And the rules here you get in there is if all the answers are yes and not action or not available, then you get a yes, a suggested available. And if one answer is no, then you get a suggested no. Okay? And finally, well, you have two more, but I'm going to work in this slide. The last one, the custom action, which mainly means that you want this value here, let me draw it, this value here, you don't want, well, I'll put it here, sorry. This value here, you don't want to be put by hand. You want a computer, a process, an automatic process to do it for you. For example, you want to verify, let me put you a quite stupid example, but you would like to verify an architecture, and you would like to verify this architecture just by checking that you have at least 10 different subsystems named in the way you would like. So you have predefined 10 systems that must exist there. And of course, you have defined a rule that you can put the verifiable item. Imagine, for example, that is a Capella model. And then you just run a software that counts the Capella model that was built there. And then they count if you got the number of architectural blocks that you expect, more than 10, and that this, at least the 10 that you want to be there are there. And then you can get a 1 or a 0, depending on a 1 if everything is okay, or 0 depending if not. So this verification action can be automated. It can be a computer that performs everything for you. The evidences and everything can be performed by calculating a custom action. And finally, the last one is the one that we, of course, feel quite proud of, which is to use the verification action as an analysis. I will show you in a while what is a technique as analysis, managing quality. That means that the system can calculate for you the quality of the work product based on the different ways of understanding quality that our tools provide, and automatically tell you if the quality is the one you expect or lower. And if the quality is the one you expect, then you get a suggested yes. If it is lower, you get a suggested no. Okay. So, so at the end, I have just described everything here. So you can have these comparisons, and of course you can go into the suggestion that I told you before. Yes or no. Okay, so I'm going here, and I just described that previously. I'm going to go into the verification and validation techniques very quickly because you are used by far much more than me on that. So inspection. Well, you get all those that we manage. So inspection. Inspection is, as you can imagine, is based mainly on human senses. So you can read, or you can, see or hear, smell, touch, or taste. It's based on examination of the element, and it doesn't imply stimuli. You don't have to do anything on the system. You have to just contemplate or see. Okay? So physical manipulation is available in case you have to check something that is not immediately available to our senses, but otherwise it is very straightforward. Okay. Demonstration, of course, is again quite straightforward. You have to show the correct operation, if possible, against operational characteristics, if possible, and of course without using physical measurements as much as possible. Generally, it uses a set of actions selected to show that the element responds to the stimuli. Okay, and the observations are made comparing expected or predefined responses. It's a demonstration. You have to demonstrate that an aircraft leaves with a particular weight, for example, then you just demonstrate it just doing it. Test. This means it's performed on the system, on the element, but in a very restricted and limited environment, mainly on the labs, if you can say. You can put these on conditions that are usually not the real operational ones, but you can do quite a lot of things on there. I like very much the example of IKEA. I don't know if you know IKEA in your country. You get IKEA, which is a furniture company that has a lot of different furnitures, and you can buy them and mount them at home. And I have seen many times in IKEA in my country, which you go along and you can see, for example, that there's a cupboard that is open. It's a machine, a motor, an engine that is opening and closing a door once after each other. And then you can see there in the display that this has been 450,000 times. And every time it's open, it's just one more, 450,000, 1 and 2 and 3. And this, of course, is in a test environment because the momentum and the acceleration is always the same, and then there's no heat. And this is very, very test-oriented aspects. Analogy or similarity based on the evidence of similar systems that happen to work on environment similar and experience before can allow you to say that you can verify or validate using these similar conditions. So it is made when other verification or validation techniques are very, very expensive. In most of the cases around space systems, where you have very few possibilities to validate the system because then you lose the control in most of the cases out of it. So it's done for that kind of cases. Sampling, more for production, mass production elements and statistics, that's more quicker. Analysis, which is based on analytical evidence, modeling, models, mathematical probabilistic calculations or logical reasonings, eventually simulations, and it's used when testing, when touching is very difficult as well. Okay, so this kind of modeling and simulation tools works quite well. And then the one that I told you before, which is a way of doing analysis technique, but it is quality analysis. When the analysis is just modeling the quality of the system, which is of course a model. You are doing a digitalization of the quality, and this digitalization is calculated through a very, very quick way of describing that I'm going to do. So I'm going to very quickly go towards how to, for example, provide a framework for verifying or validating through quality. Okay, so in order to manage quality, we use our tools, RQA particularly, which is the most famous tool that we have in the market. And in order to calculate the quality, we define quality characteristics, for example, correctness, consistency, completeness, the three we provide. And one characteristic can be mapped, or let's say calculated using quality metrics. For example, for correctness, you can use as a quality metric, for example, the length of a requirement. If you want to calculate correctness of a requirement, you can have many metrics, but one of them, simple one to express, would be the length of the requirement. Then, of course, you have a value, for example, 28 words, and then you have a quality function that describes how the length of the requirement is accepted or not accepted based on this value. This is a bad quality here, it's bad quality here, medium quality here, medium, and here's a good quality. And then you just map this element into this value, you get a qualitative value, good or bad. And this can be applied also to many different models, not only many different work products, not only requirements. Okay, this is, you have a taxonomy of the different things that you can get into correctness, consistency, completeness. And here's an example. For example, the text length that I show you, or for example, for completeness in requirements, going back to requirements, if you define the number or the types of requirements that you would like to have, and then you find only these two types, and this is automatically calculated in RQA, and then this means that you get a 66%, and this put you here, so this is a bad quality. And the model for models is the same. You can define different metrics for whatever you would like to calculate on the models. For example, here you get some metrics provided by Simulink, or you can have some metrics of breakdown structure comparison, and you apply the same processes. And here is the connection between quality here, quality, and V here. So this is the line. So you get all these processes for calculating a quality value. And then once you have this quality value, based on a verification action configuration, if you say, I only want to accept as verified those elements that have good quality, then you can automatically translate that into a verified. Okay, and of course, no is no, and medium is no. And here is a little bit strange because medium is yes, but this doesn't mean that it is done by our tool. It is done by a human. So it was a medium. The tool said no, but a human then says yes. Okay, and that's it. Okay, so here's the verification action window that you can get in the V&V Studio. We'll see a demo there, so that's not big issue. Let's go back to our tools, and sorry, to our webinar. Okay, now the last part before I show you a demo, and this part is what kind of activities do we have to do when we have to do a verification process. Let's go back to the standard and let's see what it says. Of course, the standard has the IPO diagram, and then there's the inputs and the outputs. And of course, you are aware of all of them. I'm not going to go through them. And then you have the activities of the process. And these activities are quite simple, either for verification or for validation. Or the three of them are prepare for verification or prepare for validation, perform verification or perform validation, manage results of verification or manage results of validation. Let's go very quickly through them. And then we just map these activities towards our tool. And then after that, I will show you a demo. So we have to go on the prepare for verification, perform verification, and manage verification if we just talk about verification. And here is what we have to do in all these stages. The first one, activity, prepare for verification. We have to develop a strategy. So that means, well, we have to do 4 things. Develop a strategy, develop the verification procedures, identify constraints on the system or system elements, and ensure the necessary enabling systems. Okay, so develop a strategy, which mainly means prioritization of the verification actions, defining of different verification actions, determining what to verify, establish some verification constraints themselves, the scope and everything. And the develop verification procedures is mostly to schedule those execution of verification actions. define the configuration management of verification actions. Then after that, in the constraints, so you can have all these necessary constraints based on the notion of certification, for example, or even financial constraints or other constraints that exist there. And finally, and in many cases, very, very important, the enabling systems. In most cases, eventually you have to design or to develop or to fabricate or to build specific systems to verify or validate. So it's very important to do it during the prepare of verification. In the perform by verification, we have to, of course, implement the plan, the verification plan. Okay, the item to be verified, the results that we want to get, and the methods that we want to use, the data needed for doing this, and of course to enable the enabling systems. Okay, that we prepare for them. And then we have to execute, which mainly means to use the verification actions and procedures, and of course, finally, to analyze the verification results. Which analyze them, not to treat the result, but analyze them to see if the success criteria is done, or to check everything that indicates conformance. Okay. Finally, managing the verification results, which we have to do 6 different things. Identify and record verification results. That's what we do using the verification actions and digitalizing them. And then, of course, manage the requirements verification traceability matrix, of course, record and normalize. And these anomalies have to be also managed digitally and define the corrective actions and improvements, establish and maintain the traceability, very important in verification, between the different elements and the origins and the sources and the verifiable items and the source items and so on. Provide baseline information for managing configuration, update the verification strategy and schedule in case of needs, of course, depending on how we're going, the sources we have and everything, and of course, coordinate verification activities with the project manager. Okay, some common tips. Typical are not mine. These tips are coming in the handbook, or the systems engineering handbook. So this is not something I tell you because I mean they are straightforward, but it's not something that I just simply tell you. Okay. Beware the temptation to reduce the number of verification actions due to budget. Try to avoid that. Try to estimate in the progress of the project. Try to estimate the risk about not doing all the verification actions. So if you have to leave some verification action not done, try to evaluate which risk. Try to do a typical risk management. Okay, try to see which verification actions give less difficulties if not done, which one are critical and very easy to solve, and put them in first and so on. Each system requirement, in order to use requirements, must have a particular characteristic to define, I mean, to be built with, so that we can use them in the verification process. Okay. Try not to do verification and validation at the end. Try to avoid that. Remember, we can do left-to-left verification. And don't use testing only. You have many possibilities to do. Not only testing. You can do many other things. Okay, let's get into how to do all this theoretical, even if I have been merging at the same time I was talking theory, merging with our tools. But let's do it in a way that you can see how to do that in the VNV Studio. Okay, the VNV Studio, as you know, I'm sure you know, is a tool provided by Reuse Company. So, in order to prepare, these are the different activities, and we are going to show you how to implement these activities that the standard defines on our tool. Let's start with the select the items to be verified. Okay, so how to do that? I showed you it a little bit in the beginning. You have to define a connector. So you don't have to redefine inside our tool which are the verifiable items. You just simply connect to the tool that has them. If you want to verify requirements against, for example, the guide for writing requirements at INCOSI, you just connect to a requirements management tool. If you want to verify models against whatever architectural pattern, then you have to connect to a modeling tool, and so on. If you want to verify the system, and the system, of course, is not the system because system is physical in the case of an aircraft, and you have to simulate or digitalize the system itself. You can, for example, get to a breakdown structure, product breakdown structure you have, where you have the system and its subsystems, and then you connect to it, you will get the system there. The second part is define a verification action for each verifiable item. So you have to implement or assign the verification action to every single item connected to in the previous section. In order to do that, you can use a template. So at the V&V Studio, you can define templates, which are verification actions filled in the level at the level you would like, which then are going to be somehow instantiated into the different verification items. Okay, so you can define templates for everything. Okay. Prepare resources of all type, which mainly means to fill or define how are you going to use labor, estimated labor, or funds, money, or time to do that. And define the techniques that you would like to have in the way I told you before. Those manual techniques that human must go and do, or those automatic techniques, as I told you, that you can have with the custom action or the quality tool and everything that I told you before. Let's get into performing the verification. In order to perform the verification, you have to do three things. The first one is execute the verification action for each verifiable item. If possible, if it is possible, as you have defined a verification action, the computer can calculate the comparison. Okay, so but in any case, you have to somehow fill the verification actions, the result of verification actions. In order to do that, the human fills, put the information in there, and then once the information is in, you can just go into the verification studio, V&V Studio, and you just select one of the options, and then you say calculate the result. So you have connected to the source, to the elements, then you have filled the verification actions, either manually or automatically, and then you just go and click say calculate. And once you calculate, then you get the following, which is the computer compares the expected value against the planned value and suggests yes or no. The computer does that. And it's going to give you this information for all the verification actions. You see, for example, here, it's suggesting you this yes, and this is telling you that there's no information. Okay? And finally, the human must say yes or no for each one, which means that the human just signs the verification action in a way saying that why this person has decided yes or no, finally. Some records are there and the date and which person did it and so on. And finally, once you have done that, you prepare first. You see, it was to define a connection to a source. Then you define a template. You assign the template to the verification, to the verifiable items. And then you just fill the verification action. Then you ask the computer to calculate things. And then you have humans that say yes or no. And now we are in the manage of results. Then we have manage of results. You have the anomalies that you can fill and define. And then you can define a configuration management. You can go incrementally defining how the situation is and going into several rounds to solve the problems that you have found on the different anomalies or some blocking elements. Then you can also at any time manage the requirement traceability or verification or validation matrix. And of course, you can define all the report you would like using Microsoft Word. Okay. Here's the process in a while. I'll just leave it to you if you want to see it in the video. Let's go into the demo. In order to do that, I'm going to run it from here. So let's start. So you see here's the V&V Studio, and you get here Let me go a little bit back so I can talk as much as I want. You see here, this is a connectors panel. So you get here the possibility to connect to many different tools. As I told you, you can connect to many requirements management systems or modeling systems, and of course, many other different systems. So if you just select one of them, I'm going to show you what I'm going to run in this video. So we are connecting to Excel in this case. So in this Excel, we have 5 Excel sheets. And we have the first one that you see here is a critical design review. So we are going to verify a critical design review. So we have to do a critical design review, and we want to verify that the critical design review works. Then we are going to verify some kind of system requirements in a way using analysis, quality analysis, particularly consistency of the requirements. We're going to check that there's no inconsistency on the system requirement. And if there's no inconsistency, we are going to accept that the requirements are verified. And we're going to do something on the stakeholder requirements. I don't know which order, we will remember, we will see now. So we are going to verify stakeholders again using quality, but in this case, correctness quality. And then we are going to use a system. We are going to verify the system by filling inspection and demonstration and some automatic running on the system. That mainly means that we are going to run some simulation on a FMU. We are going to run an FMU to check that what the system is described. In this case, I think it's something on the battery or something like that is fulfilled by the FMU. Okay, so the first thing we are going to do is we're going to open the BMB Studio. You get the BMB Studio, and then I would like to show you the different possibilities that exist on the BMB Studio. The BMB Studio includes RQA. For you guys that are aware of RQA, the tool, the BMB Studio is a super tool. In the case of that, it is on top of RQA. BMB Studio includes a full version of RQA. So that means that you can calculate in the BMB Studio, you can calculate the quality just for quality assessment purposes, for the process of quality assessment. If you don't want to use the verification and validation management of the BMB Studio, you only want to use RQA, then it's completely possible. Okay? So in order to do that, you see, we are now running RQA in the normal way, for those of you who know. And now we are seeing the verification view. And now we are seeing the validation view. And then we have a full view. Okay? So you can see that it's configured in a different way. In order to manage templates, if you remember, if you go back to the template section, what I told you, so you can see that in the BMB Assurance, what we do is managing templates. So you can see that we call it baselines, but it's particularly templates, and you can create here types of doing verification. So you can define that, and then simply reuse them when you are doing an actual verification process. So for example, you see there that we have a preliminary design review verification by checklist. Is a baseline where we have defined in this template, we have defined the 200 questions that you can ask when you're doing a CDR. Okay, and then they are there. The only thing you have to do then is to instantiate it, and then you got all this information by reuse. You can see a requirements or models verification by consistency. This is the configuration, and you can see some correctness also, some linear temporal logic verification, formal verification, simulation using FMUs, or analyzing Rhapsody elements, or demonstrate, and so on. Okay, so you can predefine here types of. In the quality assurance, you can define this correctness, consistency, and completeness metrics that I told you in the video. And now you can see what is the assignments. So you get, this is the configuration for quality, which is the quality assignment of all these modules. But if you change into verification, then you can see that there are verification action templates assigned besides the design requirements. And the validation, there's nothing assigned here. So if we open a verification action template, you can see that this is done in the critical design review. That means that in this template, assigned to the critical design review verification, you can see that there's a management of checklist. So if you go there, we are now managing the template so that we can manage, create, or change questions. We get into the questions, as you see in the configure checklist, you get all the different questions that exist here. We have just created 125 questions. It is. You can put some rationale there also to describe what is it that you have that the user, the engineer should have to verify. Okay. Then you can create, remove, and manage all these questions here. And remember that the verification process is that if all the questions are yes or they are not applicable, then in that case, then you would get a suggested yes. Okay. So let's start with it. Let's go into the CDR and then just simply see that in the critical design review verification process, we have two lines, and it is already giving us a suggested yes because I have just run it before. You see, this is suggested yes. So now let's get into verification. We just run, click here, and now we are actually performing the verification. So what we have to do now is to complete the checklist. So now we have a different view. We have the questions and we have to say yes or no. You see that there are many yes and some no, and some are not action. I think there's not action. I didn't see properly, but I think there are not action. Okay, so you can change everything. You can answer, and these are not action, all of them. Okay, so now I'm going to put a no one. You see that you up there see that there's one that is no. So that means that something was not fulfilled. You can include there the whatever reason, and then you're done. Well, of course, there's some history changes that it tells you what is being done, and of course now the verification action suggested yes is out of date. We have to recalculate. We call the tool to recalculate everything. So you see now it's suggesting us a no. The main reason is because not all the answers are being provided by yes. Okay, the evidences is going to tell me that there's some no's. So if I change this one, of course I can see that there's no no's, and of course if I just recalculate everything, we'll get suggested yes. And of course then a human engineer must then say yes or no. And of course it's time for us to say, okay, you suggested yes, I say yes, and I say why? Just because I think all the questions were just described yes, and I didn't see any argumentation against it. And that's it. It will change from the suggested yes into the yes. Okay, include here some argumentation, images if you want, or videos if you want to put here, or links, or whatever you would like to put. And of course, all this information, if you want, it would just join the documentation that is produced. Now, let's get into stakeholder requirements. Yeah, there it is. Now we change and we connect to 786 stakeholder requirements. 640 are requirements, the rest were not. And now it's time for us to verify them. And we are going to use, you see, correctness quality metrics. So we are using VMB Studio quality analysis. You get all this information there. And this means that we are going to calculate the quality, and we expect 3 stars. So if we have a requirement that doesn't have a quality of 3 stars, this will be suggested not to be verified. So it's time for us to calculate. So we have defined, you see, it is going to be fully automatic. We have predefined, okay, we have to show you before which are the metrics that we are going to use in order to calculate. Remember, we are going to calculate the characteristic correctness, and we are going to check the possibility to analyze through several metrics. And I'm going to show you in a while what kind of metrics are we using. But you see, for example, that there's many different wrong metrics. So precision, it's no imperative mode, and the length is very long. It's quite long. We have a lot of pronouns and many things. Okay, that you can change using the RAT. I mean, this is a VMB Studio demo, but you can go in the RAT there that I showed you before, and you can change the text of the requirement. It will be changed back to the source, doors or PTC or whatever. So now we are calculating, before we calculated the quality, and now we are calculating the verification. So that means that those, you can see that those verification actions that has based on the quality of the requirement has 1 star, 2 stars are suggested no. Okay, so that means that we are going to run now this calculation, and now we see that we have suggested no, suggested yes, and of course always it's possible to decide for the human what to do. For example, in this one, because of whatever reason, we are going to say that no, this requirement, I want to have this as yes. Okay, and just why? Because I think it's good. Even if the quality of this requirement is bad, my argumentation is that it is good. So I will do that. Of course, you can do these movements in groups. So you don't have to go one by one. You can select 20 of them, 30 of them, and then you can, of course, verify or validate to a particular state at the same time. Okay. In this case, a yes is going to be a suggested yes is going to be a no, and a suggested no is going to be a yes. And then you see different colors. It's more intense, the colors of red and the green. Let's get into properties. These are system requirements, as you can see. Okay, there's something in the video here. We're going to show now the snapshots. Okay, so that means that this is the situation today. You see, the 42% is no, and the 38% was suggested no, suggested yes, 1 no, and 1 yes. Okay, this is what is shown. So what we're going to do now is to show you that you can just create snapshots of the different system actions. So then you can see that if you create a new snapshot today with the situation, you will be able to check how it is. And you can also always go back and double click on one of the previous snapshots to see how the situation was with all the different requirements of the state, the quality calculated at that time, the evidences that we had, and so on. So now we're getting back to the requirements, property requirements, which are system requirements, particularly based on properties, and we are going to use consistency. Now, another quality calculation, automatic, you don't have to go one by one and to calculate. You're going to calculate the quality by using RQA. And of course, I'm going to show you in a second the metrics that we are going to use. But before that, there it is. We are now quality assurance, and we are going to show you the metrics. And particularly in consistency, we are going to show you these 4 metrics that we are going to use. You see the enable one, the 4 one are enable, and these metrics are going to check, particularly the first one, aggregated properties consistency. That means that if you are asking for example, weight, it's going to check that the weight of the system is compliant with the weight of the different parts. You will see now in a second in the demo. Okay, so we are going to work on the system, air conditioning system with the compressor, the fan, and everything. And we are going to automatically calculate that what is said there about consumption, power consumption, is proper. Okay, so that means that now we are going to calculate quality. So that means we are going to check the consistency of the requirements. And of course, it is prepared to show you that there's some problems. So if we want to verify this specification, we're going to get a no, because there's one requirement that is saying that is inconsistent. Okay, we calculate now. Let's go and calculate. We are going to verify this specification based on this quality, and it's now telling you no. This one of them is suggested no. And if we go and see why it is, what the reason why it is, then it's going to mean that it is because there's evidences that the total consumption of all the different parts go beyond 2 HP, which is the one expected in the requirement for the system. We're going to, it is moving quite a lot of windows, just you have the video to go back and forth to see it, but we have here the breakdown structure we're working with, and you can see that we have 3 fan blades. I'm going to stop here. We have 3 fan blades and we have one heater, one fan, one compressor, and if we do the calculations, we have 0.8 HP times 3, it's 2.4, and then we have 2.4 for the power consumption. Even if it was given in watts, for example, the compressor, we can just transform them into the same measurement unit, do the calculations, and then compare and check that 17.69 HPs is by far more than 2 HP that was defined there. Of course, there are many reasons for that. Bad design or failure, a mistake or whatever. We are going to assume that the requirement had a mistake, that it should have to be a big number, not 2 HP, but it was a bigger one. So we change it. We just made a mistake. So we put the 20 and we save it back in the source. It is Excel, or it can be, of course, it can be other, like doors, PTC integrity, or like Team Center, whatever. So now, see, we got good consistency. So that means that now, if we go into verification, we would not have any problem in recalculating everything automatically and get from the tool suggested yes. And this now is time for us to go and say, group all together and say, yes, this specification is yes, it's okay. So finally, in order to go to the final part of this video, we have just put a kind of a miscellaneous group of elements here. We have several verification actions. In this case, these are verification actions based on different aspects. We're going to do whatever. Okay. In this case, for example, is that we have a vibration. And this is a test one, and we are going to test that this system is enabled to take care of vibrations, and we just record the video, and we just decide that if the video is recorded, we by hand put a 1. We expect a video recorded with the demonstrator, and then we expect that we put it by hand a 1, and then of course we get a suggested yes. In the case of inspection, we are going to check a video that we have the compressor is in the engine, okay? And then, of course, we record a video, and then we just inspect that the compressor is there. Okay, yeah, there it is. You see, I got the compressor, it's there. So this is, of course, another manual way of filling it, okay? You can just, of course, you put a 1 and manually fill a 1 there, and then you get a suggestion. And this one is very nice because we of course record a video, and this video could have smart things. It can have smart things. For example, you can have a video. This video, which is you're seeing there, this video is using drones or whatever with cameras, and it's checking everything. But you can do smart things using this video. For example, if the video is recording in the camera the welding elements that you have, you could have then a software that analyzes this video and counts automatically the number of screws, welding elements, spots that you have there, and then turn back the number automatically inside the obtained result. So you could be able to automate inspection as well. Just record with the video and so on. I remember, for example, a company that collaborated with us that was filming, and it was the verification of the high-speed trains infrastructures. So they did, high-speed trains with they go 400 miles per hour or more, and then you have to have a very good infrastructure. And then you have to have a lot of sensors and a lot of traffic lights and a lot of signals and a lot of electrical elements, and all those must be it must be assured that they exist before the transition of the system to the customer. So what they do, it is just have a camera put on a specific train, a very small train, and then they traverse these 200 or 400, I don't remember, kilometers of railway, and they are recording what they see, and then the software is analyzing this camera and counting and identifying, of course, the different elements and typing them and counting and bringing them back. So this is automated in here, and then, of course, the verification process is automatically done, including the evidences. So, And I think the last one, this is the third one, and the last one is we're going to do something a little bit fancy. We are going to check, in this case, everything is merged. So you can consider this as a requirement if you want, or you can consider this a property of the system that must be verified. But you can see that the battery shall provide a minimum output of 30 kilowatts during 9 years. Okay. So then, of course, you have your analysis, and then we are going to run this using a simulation of an FMU. That means that we are going to get this information from the requirement or the text up there. We're going to run it against an FMU. You see the FMU here. It's a power degradation battery FMU, which we have it somewhere there in a hard disk in our case. We have some numbers to define the parameters to start, 25 Celsius degree at 9 a.m. and the percentage of humidity and the things that you have to do for doing the simulation. And then, of course, the 9 years that comes from the requirement and the 30 kilowatts that get from the requirement or the text that is there. So we have defined a custom action. You can see here, this is a custom code. You check, you can see that what we do is you can define whatever you want, exactly whatever you want in C language, okay? So then you define it there, and then we run that, and we run against this FMU in this case. And of course, it's going to tell us in this demo that it is wrong, that it is 9 years is not possible to reach with these 30 kilowatts and the simulation of how the battery is working. So then you get all your evidences, and then it tells you that the duration, the proper duration is 7 years for the simulation. Of course, I'm going to do the easiest part, which probably is not the right one. The easiest is just simply to change the text up to the 7 years instead of, for example, doing system reconfiguration, system redesign, or whatever is necessary. I'm going to do it for quickness sake to change into the 7, and then of course you will see that now suddenly this simulation is out. And the good point is here that the process is automatic. You just define everything, predefine everything in the template, and the only thing you have to do is run this VMV. You run it, and then you get the values, you see the evidences, you decide how to operate with the anomalies, and then you run it again, and you run and run and run to get your values. You can get your snapshots and define your life cycle for the verification as well. Okay. So I'm done. Cecilia, this is everything from my side.
Okay, thank you very much, Juan. Juan will answer your questions in a couple of minutes. So if you want to ask him anything, you can write down your questions in the chat box. Meanwhile, I will tell you about our next webinar. Writing high-quality requirements based on ISO, IEC, IEEE 29148 and 830 international standards. System requirements are usually written in unconstrained natural language, which is quite imprecise. At the Reuse company, we have developed a knowledge library to be used on our systems engineering suite that takes the benefits of these international standards, which provide a unified treatment of the processes and products involved in engineering requirements throughout the life cycle of systems and software to enhance the quality of requirements. The library incorporates patterns and metrics based on these standards to bring guidance for high-quality requirements. In this webinar, you will see how our systems engineering suite, together with the library we have developed based on international standards, can improve the quality of your organization requirements and your requirement development and verification. The dates for this webinar are the 24th and 25th of February. So let's see if we have some questions. Can this software be used to provide digital verification to requirements written in foreign documents by finding the requirements inside paragraphs?
Okay. Yeah, I think. Yeah. Let me answer you by understanding first your question. I think your question is if we could use as a source for identifying verifiable items, documents coming, or requirements, or whatever elements coming from external documents, like, for example, Word documents or PDF documents. And if this is a question, yes, the answer is yes. You can select a connector. You can define that the source of your verifiable items can be a Word document or a PDF document coming from, I don't know, OEM or an organization. And of course, or a tier, but of course you can then produce everything. You can not only connect to the document, but also using natural language processing, the same one that we use internally, to identify which elements within this document exist in the document, and then of course you can start doing the verification actions against them. So you will be able to select, for example, 20 or 100 requirements out of 200 document pages, and then do the standard way. So the answer is yes.
Okay, thank you. The verification action seems really unitary in front of each requirement. With your approach, how can the V&V activities be grouped in order to optimize execution?
Oh, yes, this is a good one. Yeah, let me put your question in another way. If I want to verify 2,000 requirements, should I have to go one after each other to asking them to verify, or could I just verify the whole specification? Okay, yes. The answer is that in this version, yes, you can do that with several workarounds, but you can do that. You can select the configuration of the system in a way that it shows you only the root, let's say the module or the document itself, and then you can of course apply one verification action, simple verification action to it, and then of course you can do it in one shot. The possibilities to do that is clear, but of course you are going to lose the individual work of individual requirements, which mainly means that if a particular requirement is not correct, you will not be able to run this in the same way. But what you're asking is possible.
Okay. In the case of our verification validation method other than quality analysis, to which I am familiar with RQA, how does V&V software validate other sort of evidence? For example, the video shown. The software can't see the video and interpret the image, right?
No. Yes. No. Our software cannot do that out of the box. I mean, what I was telling you about the video is done in a specific software. So that means that we don't have a software that reads a video and gets all these values. Its software is very specific, very specialized. What we do is we can allow you to whoever, you or your providers or us or whoever, to produce the software for doing this, for automatically doing what you would like. And we just simply connect to this software. We instantiate this software within V&V Studio and get the results. So the answer is we don't have these capabilities. We are, let's say, a digitalization of the verification action, but we have interfaces with many other software so that you executable files, if you want, you don't have to have anything else than an executable files if you want, but we call them. We don't have this capability natively. So that means that, for example, if you would like to run, let's say, a magic draw simulation that you have, it would only be necessary to create a small piece of software that executes this simulation in magic draw. And then once you have this software, we call that software and we get the results and put them in the V&V Studio. So sorry if I misled you, but we don't have the possibility to run everything. We have the possibility to call external software to get all this done.
Okay. Deployment of a model-based systems engineering approach is growing in the industry. Do you anticipate any change in the way of defining verification action?
Oh, that's a good one as well. Yes, of course. MBSE is a wave that it's going to stay here. I don't think that everything is model-based. I don't think so. I think that there's the best approach is to combine MBSE as a new technique, another one to do quite a lot of things. But it's clear that model-based systems engineering allow us to automate a lot. So my idea is that if you use, if with the wave of model-based systems engineering, the verification actions would automatically be affected positively, in the way that it would be very, very much possible to automate the verification and validation action, at least the suggestions for the computer. The evidences could be very well calculated and proposed to the humans. And then, of course, the work on the verification and validation would be a little bit in the way I have been showing you today in the tool. Run, define. So that would be how I see the verification and validation in the future with the model-based systems engineering. It would be a little bit like that. I see very expert people defining in the preparation, the prepare for verification activity, defining very well templates for verification, most of them in the analysis part of the analysis verification technique, either quality or either pure analysis with models and the digital twin approach and all that stuff. And these people define very well what has to be run and calculated, and then the verifiers are a kind of managers that see the evidences provided by the system, by the tools, by the simulations, and by the analysis themselves, and judge these evidences. So they don't have to go in field; they have to get the results of the analysis, judge if they are enough as evidences for yes or no. And then get into the digital management, saying yes or saying no. So I see a huge impact on model-based systems engineering and simulations and modeling in V&V. Yeah.
Thank you. Let's take a last question. Can we do configuration management of V&V results in this tool?
Yes, we can do that. Yes. If you go to the section with all the graphs there, you can define, you can see the scoreboard of how the verification and the validation is. Let me go a little bit towards that. Okay, so if you want to do configuration management here, the only thing you have to do is you define of course, the verification process as we have done. You run it. You get not only how many verification actions are suggested, yes or no, or not applicable, or yes or no, but you can also see how the time is being managed, or how the labor or how the funds are going in these graphs. And then, of course, as soon as you define a snapshot, this snapshot is being defined here, and it's creating you these lines, and you're seeing the evolution of this verification or validation process. And you can always go and double click on these lines here and go and see exactly the situation of the verification process at your system, the requirements or the model elements that existed at that time, the way of writing them, the evidence that you have for the verification element, the verification actions and their own values, everything is in there, so that you can go and see. What we don't provide, and we did it on purpose, perhaps it's wrong, is the possibility to roll back to a previous state. So if you cannot go back to the verification situation that you had, let's say, the 7th of April in 2020. You cannot, you have it there, you have everything there, but we didn't provide a possibility to roll back there. But besides that, everything is provided there.
Okay, thank you, Juan, and thank you everybody for attending. If you have any further questions or want more information about our tools, don't hesitate to contact us by email to contact@reusecompany.com or through our website, reusecompany.com. Thank you very much and goodbye.
Thank you. Goodbye.